Okay, so welcome to this video where we are going to solve a question based on projectile motion. So this question goes like this. We are saying a rock is thrown horizontally off a 100 meters cliff. It lands 95 meters away. At what speed was it thrown? So here you find that if they tell you to say the object was moving from a cliff and then it lands away from the cliff at a distance of 95 meters, what you should always do, first of all, you need to sketch. The sketch is very important on this moment of time. So this is the cliff. Then the object was thrown horizontally. It had the initial velocity v initial, that is horizontally. So this object, if you throw it horizontally, you find that it can't just move and then it will move on like this. No, it will move like this, then it will take that given path and land at this given point away from where? From the cliff. So the distance which is at this given point, you'll find that this object is not making a symmetrical path. So since it is not making a symmetrical path, meaning that here the formula is 1, the formula of time of flight, it can't apply. The formula for range, that other formula which is equal to v sine 2 theta over g, you'll find that this can't even work. Reason being, this one is not a symmetrical thing. Again, we don't have the actual height. The maximum height here, it also can't work. Reason being, the thing is not making a symmetrical path. Now, meaning that for you to easily find what exactly it has to be the initial velocity, you are going to consider two different scenarios. You consider the height and also the horizontal distance. This one has to be x. This one, the height here, it has to be your y. So what you are going to observe is, for you to easily understand to say what answer is going to come out once you use these two different expressions. I said if you want to find the distance from here up somewhere there, we normally use this equation. X has to be equal to v initial cos theta t. And then you are going to observe that here we don't have the angle. The angle is going to be equal to what? 0, because this thing is moving towards the positive side, whereby if you use a compass, you find that it is going to be a 0 degrees. So meaning that this one is going to be 0. If you say x has to be equal to v initial cos 0, you are going to understand that this is going to be equal to 1, sorry. So 1 multiplied by everything, we are going to get something like this. And what you are going also to understand to say, the time this object is going to take to move from here landing up to that given point, it will have two different things. It's one and the same, like if you are trying to throw an object vertically downwards, then this one has been rolled in that given direction. These two objects, they're going to take the same time. They're going to take the same time to land up this given point. And it's true. It's true. They're going to have the same time. This one to land at this given point and this one to land at that given point, they're going to have the same time. Meaning that if the object was to roll like this, it will take time in y and in x. So it is going to have the same time both in y and x. Now, what formula are you supposed to use in the y like this? You'll find that if we were to use the general, or rather the skeleton equation, which is going to be v initial t plus 1 over 2 a t square, you understand it fully to say this type of equation requires us to have these two different formulas, this and that one. Now, what is this? Remember, we're trying to consider the y movement. So whenever you're talking about the y movement, I know that here it doesn't have the initial velocity in where? In short, initially it doesn't have the initial velocity in y-axis, because that's what we normally consider. Meaning that this part, it has to give us 0. Reason being, we don't have the initial velocity in y. Remember, we said this thing is going to have the same time both in y and in x. So for you to easily find what we call the initial velocity, what are you going to do? You can use this expression to get time, because we're going to have the same time. The time you're going to get now has to be replaced where there is this, and you'll be able to get that. Remember, in the x, they're saying this particle had moved 95 meters away from where? From the cliff. Meaning that this distance which is here, it has to be 95 meters. And then the height of the cliff has to be what? y has to be equal to 100 meters. Okay, so if you proceed, you understand it fully to say here you just put 100 meters and I'll say equal to, remember acceleration has to be acceleration due to gravity at this moment of time. So we're going to have 1 over 2 multiplied by, alright, I'll take acceleration due to gravity as 10. Take 10 t square. So if you do like this, you find that this is going to be 5. So if you divide by 5 here, you divide by 5, we are going to get t square, which is going to be equal to 20. You square root, and t is going to be equal to, if you come here, you'll find that if we say, we put it here, if we say square root of 20, we are getting 4.47 seconds. So we're getting 4.47 seconds, meaning that this time it will be the same time it will cover in x and y. So you can just use the same time and find the initial velocity, whereby this one has to be 95. So we're going to have 95 equal to v initial 47. We divide throughout by 4.47, even here 4.47, like this, meaning that the initial velocity here has to be equal to, we are going to say this has to be 95 divided by 4.47, and definitely it gives 21.3 meters per second. Then you are done. This is how you have to be solving such kind of questions. Remember always the movement in y and x, they all have the same time. But if initially it was rolling like this, it was rolled horizontally, it won't have the initial velocity in what? In the y-axis. Thank you for watching.